Okay, thank you, Mike, for asking this question during class today. I figured a video solution would probably be more expedient for the use of classroom time. So let's go ahead and take a look at number 8. A mass M at the end of a spring vibrates with frequency of 0.88 hertz. When an additional 680 grams is added to that mass, the frequency has been reduced to 0.6. What's the value of M? Let's go ahead and start writing some equations here to see if we can't figure out a way to get through this. I'm going to use red to denote the what's going on with the first setup. So 0.88 hertz with that mass M. So let's go ahead and write that the frequency of the first oscillator equal to 1 over 2 pi times the square root of k, unknown value, but divided by that mass. So let's go ahead and just write that. It's one of our equations that's on our board. I think the one on our board involves period, but remember period is reciprocal of the frequency, so we can just go ahead and write that. Let's go ahead and isolate this for k. So I'm going to square both sides. F1 squared is equal to 1 over 4 pi squared multiplied by k over m1. I'm going to isolate k. So I'm going to get k on one side. K would be equal to, let's see, F1 squared multiplied by, let's go ahead and write that as m1 multiplied by 4 pi squared. All I'm doing here is I'm rearranging the equation that's written for frequency and rewriting it in terms of k. Now, why am I doing that? The other oscillator involves changing this mass from M1 to M1 plus 0.68. I'm going to switch this over to a blue color so we can see how this equation can be written. The new frequency, which is given to us, is equal to 1 over 2 pi times the square root of k over M2. Let's go ahead and just rewrite that just like I did down here. I can do the exact same steps, and we'd get that k is equal to F2 squared multiplied by M2 multiplied by 4 pi squared. Now, when you solve a system of equations with two unknowns, there is a way to do that is to do this via, I'm not sure if they call that substitution. I guess this would be a substitution kind of thing. Both of these are equal to k. So if k is equal to this and k is equal to that, then that means these two things must be equal to each other. So let's go ahead and set them equal to each other. I'm going to stay with red for this side. F1 squared times M1 times 4 pi squared must be equal to F2 squared times M2 times 4 pi squared. And since I set them equal to each other, I can see that the 4 pi squareds will reduce out. And I see that F1 squared times M1 is equal to F2 squared times M2. Let's go ahead and now replace M2 with the fact that it's really just 680 grams more than M1. And let's just see where that solution goes. I'm going to switch over to black just so it's easier to get through all of this without changing all the colors. I'm going to replace these numbers as well with the numbers that are given up here. So F1 squared would be 0.88 squared multiplied by M. That's going to be equal to F2 squared. Well, F2 is 0.6. So 0.60 squared multiplied by, I'm going to replace now M2 with M plus 0.68. At this point now, I've gotten rid of everything except for M. There's some algebra involved to be able to get to that value, but we can do that. So 0.88 squared is 0.7744, and that'd be multiplied by M. 0.6 squared is 0.36, so that'd be 0.36 times M plus, I have to distribute that to each of those terms. So 0.36 multiplied by 0.68, this would be 0.24, I'm just going to round that to 0.245. Now I'm going to collect my terms, so 0.7744 minus 0.36 is 0.4144M is equal to 0.245. And when I divide that out, you get that M is equal to 0.245 divided by 0.4144. I get 0.591. And again, the units should be the SI base unit for mass. Since everything that I'm using here involves the SI base units, I should get the SI base unit for that mass value. So 0.591 kilograms, and that's where that number comes from. Again, thank you, Mike, for asking that question. I hope this video solution helped.